Hey students and family members, it's Mr. Panza, still reviewing even though we're currently testing in the PSSA. Let's take a look at PSSA grade 4, number 9. We've seen a lot of these questions in class. We've been talking about a K, a W, and an S. The W is what we want to know. We want to know the closest value to 79 times 4. Technically, you're not supposed to use a calculator on this one. Here's what you know. The K represents nothing tricky but what you know about the question. I know that I have the number 79, and I would like to multiply that by 4. But because it says closest, I need to round this 79. The 4 is going to stay the same, and then I eventually set up whatever I round 79 to in a lattice box. Underline, circle the digit to the right. That's a 5 or above, so I give the underlined number a shove plus 1. That turns that 7 into an 8, and all the circled numbers into the right becomes a 0, and you'll be all right, which means I should have multiplied 80 times 4. When I multiply 80 times 4 in lattice, I get 320. For number 2, we know that we cannot add, we cannot subtract, and we cannot compare fractions with uncommon denominators, which is exactly what they're trying to ask us to do here. So if I have South America 12 100ths and Asia 3/10ths, I cannot compare it. So what I have to do is change the 3/10ths. The way I do that, change the denominator using multiply or divide, and the same to the top must be applied, which means 10 times 10 gets me 100 as a new denominator, which I can compare. And then I multiply the top 3 by 10 because the same to the top must be applied, which gives me 30. And that's only going to leave me with one choice because they're comparing the amount of land that either Asia or South America covers on the Earth. And every single one of these comparisons is not comparable, except for C, because they did change 3/10ths to 30/100ths and then compared it to 12 100ths. Flip it to the back. Question number 3. 24 chocolate pieces, 2/3 of the pieces have peanuts in them. How many have peanuts in them? 2/3 of them. How many total chocolate pieces do I have? 24. Now, I could just immediately remember that of means multiply, and that's what I know. And if you have a functioning calculator that can multiply fractions, you plug it in, and you're going to get your answer of 16. However, if you don't have a calculator that can do fractions, after you change the of to multiply, step 2 when trying to find fractions of a number is change this whole number, and you can change any whole number into a fraction by placing it over 1. Then step 3 is multiply the top, the numerators by the numerators, which is going to get me 48. Multiply the denominators by the denominators, 3 times 1 is 3, and then divide. 48 divided by 3 is going to get me my answer of 16. There's actually a couple different ways to solve this, but this is the most effective way. Now I have 2 numbers on question 4, one for a baseball stadium, which is going to be part of what I know, and one for a football stadium. The problem is the baseball stadium and the football stadium right here that you're trying to compare place values to are written in written word form. So the first thing you're going to want to do is take that number and write it in standard form. Say the number out loud, write exactly what you say. 37,495 seats for the baseball stadium and 69,143 seats for the football stadium. Make it matchy-matchy by placing the numbers directly on top of each other based in place value, and then make sure you understand that, yes, I know I'm comparing this 3 in the 10,000s place value to this 3 in the ones. So if I'm moving from the ones to the 10,000s place value, you just have to count however many place values you jump. 1 place value would be times 10. 2 place values would be times 100 because every place value over is times another 10. 3 place values over would be times 1,000. And because I'm moving 4 place values over, it's going to give me 10,000 times the number or worth of this 3. which makes a lot of sense because if I took a 3 and I put it in the 10,000s, I'd replace every other place value with 0, which would mean it's worth 30,000, and comparing that to a 3 in the ones would make it look like this. A 3 in the 10,000s place value compared to a 3 in the ones place value shows me that it is 10,000 times greater than that place value to the ones. Question number 5, you should round every single one of these numbers, especially for a multiple choice question. And what do you know? You know that they're all going to be rounded to the nearest 10, so underline your digit in the 10, that's step 1. Circle the digit to the right, that's step 2 when we're rounding. And then after you round it, whichever one gets you to 8,300 is your answer. So the top one cannot be my answer because the 8 and the 2 stay the same. This 9 bumps up, or I'm sorry, this 8 bumps up to a 9, and I put my comma in the wrong place, which means it's 8,290. The second one, because this is a 5 or above, I give the 9 a shove, which makes it a 10, which jumps me over to the hundreds place value, which does mean I get 8,000. That 2 jumps up to a 300. And the other two I don't even have to look at, and even if you did, I wouldn't get 8,300, which means B is my correct response. But I do tell the students that even if you've already gotten the answer, just to limit your mistakes, check them. For the last one, you have a football league, 53 players, 32 teams with 53 players on it. Well, if you had a league with 32 teams and 53 players were on each team, really all you're doing here is multiplying, which means it would be 53 in lattice multiplied by 32. Nice thing about this is you don't even need lattice because you're allowed to use calculators, and when you check it out with lattice, you would get D, 1,696. Thanks. Hope this video helps.